Hello everyone. Today we are going to discuss about collision reduction techniques in hashing. So whenever we are going to insert a data item, sometimes collision may occur. If in that position any other data item previously inserted. So in that case you have to handle the collision. We'll see how we can handle the collision. So usually basically hash function is used to compute the hash value for a key, right? So this hash value is nothing but it provides the index for your key. Key is nothing but the data item which we are going to insert into the hash table. And so when the hash value of a key maps to an already occupied bucket of the hash table, it is called collision. As I told you, when you're trying to insert a new data item into the hash table, already that hash table position is occupied by some other data item, previously entered data item. At that time, collision occurs because already that particular space is occupied, you cannot insert any more data. So in that case, collision occurs. So we'll see how we can handle that. So these are all the collision resolution techniques in hashing. So one is separate chaining, or we say open hashing, and another one is open addressing or closed hashing. Open hashing and closed hashing are the two types of methods we use to resolve this collision techniques. So in this open addressing, we have linear probing, quadratic probing, and double hashing. We'll see one by one. So first is separate chaining. So this is the first technique to handle this collision. Here we are going to create a linked list to handle the collision. So already a data item is present in that hash table location. We are going to have a linked list and we are going to place the second item in that linked list. So that is the thing we are going to do here. So the new key is then inserted in the linked list as I told you. So this technique is called as separate chaining because we are going to maintain a linked list for the collision occurring data items. So that we are calling as separate chaining. So here we have to find the load factor. It's a very important thing. So load factor is equal to number of elements present in the hash table divided by the total size of the hash table. Okay, total number of elements divided by the total size of the hash table. So that gives your load factor. So here let's consider an example. Here using the hash function key mod 7. Okay, key is nothing but the data item modulo 7. 7 is my table size. So these are all the elements I am going to insert. So here, so my table size is 0 to 6. Now the element is first element is nothing but 50. So 50 modulo table size is what? 7. 50 modulo 7, it gives what? Modulo gives remainder 1. So 1 at location 1 I am going to insert 50. Okay. So this way I can do the insertion process. And next is next value is just consider 700. So 700 modulo 7, right? 700 modulo 7, it gives 0, right? Remainder is 0. So 0th location I have inserted 700. And next value is 76. So 76 modulo 7 is 6. So 6th location I have inserted 76. So this way I can do it. And just see the next value 85. Okay, 85 modulo 7, it gives what? 1. Okay, 85 modulo 7, it gives 1. So at location 1 already 50 is residing. 50 is occupied at location 1. So what I have to do, I have to create a linked list and I have to place this 85. Okay, at location 1 I have to create a linked list. I have to connect this 50 with 85. So in this fashion I can create linked list and I can insert things. The next value is 92. So here 92 modulo 7 is what? 1. So again I have to create a linked list at the in first location and I have to insert 92. So 50, 85, 92 is residing at location 1, but I have created linked list for collision occurring data items. Okay. So this way, this is called a separate chaining. So in this fashion, we can create linked list and we can store the collision occurring data items. Thank you.